When a type checker lets you omit types or write question mark in place of some of the types, we call that type inference because, again, the checker is going to figure out what type you should have written there. There is some type. So when a type checker supports inference, and it has an omitted type or it sees a question mark here, it's going to make a type variable, like t1. And so it'll say just at first that x is of type t1 for some unknown type. As the type checker continues, it'll say that 1 has type int, and then we know that the type of plus overall is integer as long as the two sub-expressions are of type int. And since we have a variable t1 that was formerly unknown, now we know that it must be integer in fact. And when we make that assumption, then overall this is a function of type int or int. So inference is going to create a new type variable, like t1, for each question mark that it encounters. So it'll be a fresh variable that starts out unknown. But as a type checker would normally check that the two types are equivalent, it's going to end up installing equivalences. That is, it's going to change type variables to record that, in fact, this type variable must be some other type. And as long as it can do that without hitting a conflict, then we'll have a type for the program overall. Here's another example to consider. It's a function that takes an x with an unknown type. So again, we create a type variable t1 there, and use it when we get down to type checking the else case of this if. Overall, if needs the expression where true is to be a Boolean, that works out. It needs these two to be the same, so here again, t1 will end up as int, and we'll get int or int for the overall function. So you'll notice that's a place where we were doing an equivalence check before between two types, now turns into installing some equivalence. How about this case? We've got an argument x unknown, so we created a type variable t1. We also type check the then and else cases. Now here, when we check that x is a Boolean, we will set t1 to be Boolean. But when we check that the then and else cases are the same, we'll try to set t1 to int, and that is a conflict. When you run into that conflict, that means there is no type that you could have written here that makes things work out, and so the type checker will fail and not give a type to this expression. How about this case? Now we have an argument y with that's unknown, so its type is t1, and we end up with t1 arrow t1 without ever having to pin down t1 further. We get to the end of type checking. And that's okay. This is an example where more than one type could have worked in place of the question mark. So rather than just arbitrarily picking a type to put in place of the question mark, the type checker will just leave variables in the reported type.